Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It's my pleasure to introduce Mary Ringel Morris, and she's here interviewing for a position in either the ASI group or the Vibe group. We're happy to have her. Mary is finishing up her PhD this spring, and she's been working primarily on collaborative software and interaction techniques for tabletops, and she's going to talk a lot about that today. But she's also interned with us previously, and she has all kinds of broad interests in the area of search and novel ways of doing collaborative searching and suggesting. So please take it away.
Great. Thank you. So as Mary mentioned, today I'm going to talk about my dissertation research at Stanford on supporting effective interaction with tabletop groupware, in particular looking at the question of whether user interface design can positively impact group work styles around these new devices. So currently, most computing systems are really designed to support a single user working by him or herself. But of course, there's a whole field of computer-supported cooperative work that looks at how you can extend computing systems to support collaboration among multiple users. Over the past decade or so, systems that support collaboration among remote users, such as email or chat and video conferencing, have really become mainstream and are very popular and usable. However, systems that support the other side of this chart, supporting teams of co-located people working together, are still less commonplace and less commonly used. There's been some research, for instance, the Messy Board project at CMU is an electronic bulletin board that's meant to support awareness among people who work in the same area but aren't necessarily present at the same time. There have also been projects such as Stanford's iRoom project and other similar ubiquitous computing spaces that are trying to be on the forefront of looking at how you can support team meetings more effectively with technology. Today, I'm going to focus on one particular aspect of some of those enhanced meeting spaces, which is looking at how software can be created for interactive tabletops. Co-located group activities are an important part of many aspects of our everyday lives. In professional contexts, people gather to work together on projects or for meetings. At school, students work together on class assignments and homework projects. And even in our homes, people gather together as a family both for recreation and entertainment, and also for more task-oriented activities like planning a vacation together. One thing that a lot of those co-located tasks have in common is that people often gather together around a table when they're meeting, working, or even for recreation. And as you can see, tables appear in a wide variety of contexts in our everyday lives. So why are tables so popular? Why are they the focus of so many co-located group activities? Well, there are a lot of reasons for that. One is that they afford face-to-face collaboration. So you sit across from the people you're working with, you have a clear view of them, you can make eye contact, which is an important aspect of communication. Another interesting thing is the types of work habits that tables promote. So for instance, there's some work in the social sciences that compares work styles around traditional tables to groups who work at whiteboards and chalkboards. And what they found is that when people work together at whiteboards, usually there's one person who kind of emerges as the leader who dominates a group activity, whereas tables have a more equalizing effect. They encourage more turn-taking and participation from all group members. Of course, tables tend to have a large surface area, so they afford the spreading, piling, and organization of information. Because they're a horizontal form factor, you can place tangibles and other objects on top of them. And finally, if you're working for any extended period of time, it can be comfortable to be seated at a table while you work. What would be great is to combine these benefits of the traditional piece of furniture with the benefits of digital technology. So for instance, the ability to archive what you've been working on, to access a lot of data from remote sources, to quickly search through large amounts of content, and to be able to save what you've done in a way that makes it easy to share with others afterwards. And of course, as you won't be surprised since you're here to hear me talk, that solution does exist, and it's what we call an interactive table. Interactive tables are a form factor that have really been emerging over the past couple of years. And in case you haven't seen an interactive table before, this gives you a taste of what it's like. Multiple people can all interact with the surface at the same time. They're all seated facing each other. The surface is large. This is the Diamond Touch device that you see here. There are a lot of applications that can really take advantage of this new technology. I'll give you a few examples here, some of which I'll talk more about later in the talk. For example, in the educational realm, these make a great platform to support existing small group work practices and enhance them with some of the benefits of digital media. One interesting application area that we found at Stanford is working with members of the biology department who go on expeditions to exotic places where, unfortunately, I do not get to go with them. But they go and they study the flora and fauna, and they take a ton of digital photos. And when they get back to the lab at Stanford, they need to label these photos to identify what species are depicted, which experiment it was part of, etc. And it's useful for them to do this task in groups, both because they go on the experiment, they go on the expedition in groups often. People have different expertise. So one biologist knows about leaves and one knows about grass. And so it's helpful for them to work together on labeling the photos to get more accurate labels, and also as a learning process to involve some of the younger graduate students in the labeling task as well. So we worked with them to develop a tabletop system. Tables also lend themselves well to visual spatial tasks, such as laying out magazines and web pages. Obviously to business and productivity tasks like sharing and manipulation of documents, and also to manipulation of map data. So this has a lot of applications, for instance, in the military and also in things like search and rescue planning, interacting with map visualizations on the tabletop. This form factor has also become increasingly prominent in the past few years. IEEE just started a new conference looking specifically at tabletop interaction. The first meeting was in January. I'd be glad to talk with you about it later. It was really interesting. And in fact, some of these systems are now moving out of the research lab into the commercial sector. So for instance, Smart is known for making their large vertical style whiteboards. They do millions of dollars a year in business, selling primarily to business and educational markets. Some people, this is a picture from the University of Calgary, have begun to repurpose their vertical displays to use in a table form factor. And I've heard rumors that Smart is going to be marketing a table-specific device as well. The Mitsubishi Diamond Touch device, which I'll talk more about later, became commercially available a few months ago. And just last month at the Consumer Electronics Show, Philips presented their Entertable, which is a home entertainment device meant to allow playing of digital board games, which they'll be bringing to market soon. However, even though these devices are becoming increasingly available and popular, designing software and content for them isn't as simple as just taking a program from your traditional computer and projecting it horizontally. There are a lot of design challenges that are specific to this form factor. One is the issue of orientation. So when you sit across from me at a table, what's right side up for me is upside down for you, which could obviously have some legibility and usability issues. Another issue is considering how to appropriately manage the space on the table's surface. For instance, when laying out basic GUI widgets like buttons and menus, should you give one copy to each person around the table, using up more screen space? Maybe you should only have one copy of those widgets that everyone shares, and how would those different choices influence group work styles at the table? Another challenge is deciding on appropriate input mechanisms for these devices. It's possible that perhaps everyone would interact with an interactive table by sitting around the edge with their own keyboards and mice, but there might be other more appropriate input mechanisms as well. Integrating sources of personal information with a shared tabletop display is an important challenge. Because the surface is shared, all of the content is visible to everyone in a group, but traditional work practices include sources of private or personal content. So adding that back into a digital system in a fluid manner is important. Also, because multiple people simultaneously participate and interact with the table, coordinating the actions of users and preventing behaviors that might interfere with each other is a challenge area for these systems. And finally, considering how tabletop systems can influence team dynamics, both positively and negatively, is important when you consider the holistic design of the systems and their use in context. Sort of the bullet point, the takeaway question to think about today is whether user interface design for these devices can address those challenges in order to enhance interactive tables and allow them to more effectively support teamwork processes. That's the question I looked into as part of my dissertation research at Stanford. And to explore those issues, I built and evaluated several novel tabletop user interfaces, in the course of which I developed some new interaction techniques, and also did more formal lab studies where I compared different interface designs in order to distill out from that design guidelines that could be useful to future software designers working with these types of devices. And I'll talk about some of those systems in the next few slides. In particular, I'm going to talk about solutions to each of these challenges. Because of time constraints, I'm not going to go into detail on all of them, but I'll give you a brief taste of some of the ones that I don't have time to go into detail on. First, I just want to introduce the hardware that we use. So we at Stanford have used the DiamondTouch device, which was introduced by Mitsubishi Electric Research Labs 4 or 5 years ago. So the DiamondTouch supports direct touch input from up to 4 users at the same time. Users sit on special conductive seat pads, and when they touch the table, they're actually capacitively coupled to it. And the table can then determine which of the 4 users is touching where, depending on which of the seats that user is connected to. The device itself is actually not a display, so we mount a projector in the ceiling to co-locate the output and the input. All right, so first I'm going to give sort of quick 1-minute overviews of these first 3 design challenges and solutions because of time limitations, and I'll focus more on these latter 3 during the rest of the talk. So the first issue is orientation. And so a project that I was involved in with my colleagues at Merle was the creation of the DiamondSpin Toolkit. So this is an open source Java toolkit for the creation of tabletop user interfaces. It's available on SourceForge. And in particular, the DiamondSpin Toolkit is appropriate for tables because it provides the developer with several different ways to handle the issue of orientation on the tabletop. So for instance, you can program the background of the table to spin like a lazy Susan in order to move everything. You can program objects to automatically face the outer edge of the table, or you could individually customize the orientation of any individual object. And you also have the freedom to specify a single canonical orientation if that's what you choose to do. I'd like to also talk briefly about some of the work I've done looking at how to lay out interface widgets on the tabletop. This is work that I'm going to be presenting in more detail at the CHI conference this spring, which is looking at how you would lay out basic controls such as menus. As you might be able to tell from the screenshots, this work was inspired by our work with the biologists in an application called TeamTag, which we created to allow collaborative labeling of digital photos with metadata. And one issue when we created this application was how best to position the menus from which you choose the labels. For instance, you can make one copy of each menu that's shared by all the users, located centrally to be more accessible to everyone, or you could place things around the edge and repeat them for each user. And there's pros and cons of the different designs. For example, the more centralized design promotes more group awareness of the labeling activities. It also uses less of the valuable screen real estate. Although we found from our experiments that users vastly prefer having their own private set of controls for several reasons. One has to do with proxemics and worrying about the hygiene and bumping issues of sharing controls with other people, as well as having to do with the semantic importance of the center of the table. People like to use the center for drawing attention to items that they're currently working with, and so having controls take up that space on the table can be problematic. Again, I'll talk about that in more detail, Kai, or I'd be glad to talk about it with you later on. The last project I'd like to give a brief glimpse of is something else that I'll be presenting at Kai this spring, which is a new input mechanism for tabletop displays called cooperative gesturing. So these are hand gestures to interact with the table, but in particular these are designed thinking about the table as a social and teamwork vehicle. So cooperative gestures involve multiple people gesturing together in synchrony to create a cumulative effect. And this can be useful for several purposes. It could be used to directly enhance social and participation and interaction, which might be appropriate for activities for children, for instance. Or this type of command can be reserved for special commands in the system in order to increase group awareness about potentially important events, such as deleting large amounts of content or clearing the table. And so these gestures just use the touch input information from the DiamondTouch device. We don't use any cameras. And just to give you a taste of what one of these looks like, this is a gesture for clearing the table. So everyone makes this piling motion with their hand. And when one person does that, they only put together in a pile any photos or documents that are in between their hands the way you would normally expect. But as you saw here, when everyone in the group does that option at the same time, it has the magnified effect of clearing and organizing the whole surface of the table. And again, I'd be glad to talk about this one more afterwards, but because of time limitations, I'm going to move on. So we'll go into a little bit more depth here. This is some work that was presented at CSCW a few years ago on ways to supplement a tabletop display with sources of private content. So when people work in the real world around a table, they usually bring sources of personal or private information with them. For instance, a notebook or a laptop or a PDA. And group work tends to transition between periods of very tightly coupled collaboration and interaction and periods of more individual work where someone might step back, consult their own notes, maybe bring back something to the group. So we want to support that type of work style with the interactive table. Now, people have looked into other ways of supplementing a shared display with sources of private data. For instance, by having people wear head-mounted displays, and so they see their own sort of personal content overlaid on top of the shared display. People have also looked at supplementing tabletops or vertical whiteboards with PDAs or laptops for personal content, in addition to the shared content. And in fact, I've also done some work supplementing a table with PDAs that I'm not going to talk about here today. However, one challenge with those two solutions, either the head-mounted displays or the supplementary devices, is that they do inhibit some aspects of communication, such as eye contact. If you're wearing goggles, it's hard to make eye contact with people in your group, or if you're busy looking at your own personal device. And that can really detract from the communication and team feel of an activity. So one alternative that we explored was supplementing a shared device with the sources of private audio content for each member of a group. One thing that we took into consideration when designing our system was some results on the way human hearing works. So in particular, we only had our users wear an earpiece in one ear because there's been work that shows that people are effective at paying attention to two different streams of audio if they're presented to two different ears. So the idea here is that the system-generated audio content is presented to one ear, but the conversation with your teammates is still presented to your other ear. Because really, we want to make sure that people are still involved in interacting with their team and aren't trapped in this little private world of, listening to their secret audio messages. There are a lot of types of applications for this system. One application that we've been developing is the audio note system, which is a system for sharing digital photographs around the tabletop. So you can see an example of a photo in the corner here, and there's this little speech bubble icon up in the corner. So the way the system works is the digital photos are on the table, and if you were to touch the speech bubble icon, you would hear the photo's caption. So you can do, in addition to reducing clutter on the screen because you don't have to display that information in print, that also gets rid of the legibility issues that stem from the different orientations on the tabletop. Several people can hear the caption at once. And because the device has user identification capabilities, you can also now customize content for different users. So when I touch the photo, I might hear, oh, my parents and my brother and sister at the beach. And if you were to touch it, you would hear Mr. and Mrs. Ringel and Amy and Ben are at the beach. One thing that we wanted to make sure of when we created this system was that we preserved some of the benefits of traditional table work styles. So as I already mentioned, we wanted to make sure that we now can support these types of transitions between closely coupled and more parallel group work styles. And again, we're also interested in enhancing some of the benefits of tables. So as I mentioned earlier, there have been some studies that compare the use of traditional tables to whiteboards that have found that people tend to participate more equally and be more involved when they work around a table. So we're interested in creating a system that enhances and preserves this effect. I'll give you a quick highlight of some of the results from some studies we've conducted with these systems. One concerns the impact of the system on communication. One thing we were very concerned about was that people would be so absorbed in listening to this audio and private messages that communication would be inhibited and they would no longer interact freely with other group members. But what we found, in fact, was that all the groups who tried out both our system that was enhanced with private audio and a basic tabletop system that didn't have sources of private content, people actually always spoke to other group members more when they used our system with the private audio. So not only did we not inhibit communication, but we've actually increased the level of interaction among group members, partially because now people have the freedom to go off on their own and explore and then come back and talk with other group members about what new things that they've found and learned. We've also found that supplementing the table with private information, in fact, does encourage more participation from group members. So here we've looked at different actions that you could do in one of our tabletop systems, such as interacting with music content and matching different photos together. And this graph shows the standard deviation within groups of how many times each group member did the activity. So a lower standard deviation would reflect more equal participation within a group. And again, what we found was that our system of supplementing the table with private audio, as compared to a system without sources of private information, further enhances this effect. You get more equal participation from group members, again, because now people can go off and explore on their own. People who were a bit more shy get more of an opportunity to participate. So supplementing a table in this way seems to be one promising avenue for encouraging more participation in more natural work styles. I'm going to move on and talk about another one of our projects, which looks at handling this issue of multiple people simultaneously interacting with content on the tabletop. And this is work that was presented at CSCW and also at CHI 2 years ago. So this work was motivated by an application called Table for N, which ran on a table at Mitsubishi Electric Research Labs. It was sort of their demo application that was always running, and people would come into the lab and try it out very frequently. And so this is an application that lets up to 4 people sit around the tabletop and manipulate different types of content. So you have images, you have web pages, you have textual content. People can move these items around the table's surface with their fingers. They can also annotate and edit it, take copies back to personal devices, etc. And we saw several different types of usability problems with this application that we hadn't anticipated. For example, when people were working in a group together with this application, sometimes people would quit even though everyone else in the group had still been working. There was also a button that would let you clear all the content off the screen, and people would press this function even when other people had been in the midst of using content. Another behavior that we saw pretty frequently was people would reach across the table and take something that someone else had been in the middle of working with, or several people would try and grab the same item at the same time. So this was surprising because sort of the status quo in a lot of the CSCW community is to assume that social protocols or rules of polite behavior are sufficient to avoid these types of problems. Because people are sitting right there in the same room with each other, they should be able to coordinate their own activities. However, as we saw, and as other people have also observed in the literature, the rules of good behavior sometimes vary between the digital and physical world. And there are several reasons for that. So one is that some of the feedback that's present in the real world isn't present in this tabletop system. So if we were sitting across from each other at a regular table and I had a piece of paper and you reached over to grab it out of my hand, I would pull back, right? I mean, there'd be some at least force feedback that maybe reminded you, oh, she's using this. And that type of force feedback and haptic feedback, for example, is not present in the table system. Also, it's an overwhelming experience for users. They're not used to these types of technologies. It can be very confusing, and that can also increase the incidence of some of these problems. Other people have also observed difficulties that people can have that you might expect social protocols to account for. For instance, in Izadi's work on the Dynamo system, which is a vertical shared display, they observed that users would close other teammates' windows in order to make more space for maximizing their own content on the screen. People would also maximize their windows so that it covered spots on the screen that other members of the group were interacting with. Saul Greenberg and his colleagues have made similar observations in some of their remote groupware systems. And he actually has a nice classification where he talks about some of the reasons that these breakdowns occur. And some of them are due to confusion of using a new system. Sometimes there are unanticipated side effects of an action. So people are used to working in a single user environment, and they don't think about the fact that when they maximize something, for instance, that might obstruct what their teammates are doing, because that's not something that they normally have to think about. And of course, there are just blatant power struggles where people intentionally are rude to each other. Whatever the cause of these behaviors, these types of conflicts distract users from their main task. They interrupt the workflow. Now people have to concentrate on, oh, how do we get that back on the screen? Oh, you have to give that back to me. And they're focused more on the nitty-gritty of the user interface and not on actually being productive. So what we propose are software-based coordination policies, so interaction techniques and mechanisms that can help avoid these types of conflicts from occurring in the first place, or resolve them gracefully when they do occur. To help us design these policies, we conducted 2 surveys. So each survey described a scenario where 2 people were sitting across from each other at a table, and one person had a document, and the other person reached across to take it away. And in one of the surveys, this was a regular table, and the document was a piece of paper. And in the second survey, it was an interactive table, and the document was a virtual document projected onto the tabletop. And we gave each of these surveys to about 20 people and just asked them to brainstorm, freeform list all of the things that they thought should or could happen next in this scenario. One thing that was interesting that again gets back to this idea that for some reason these social protocols aren't always sufficient in a digital environment was that people only suggested social solutions to this scenario in response to the survey that was about the traditional tabletop and paper. So these were solutions like getting up and moving your chairs so you could read it together, or reading the document out loud so that you could both hear it at the same time. Also verbally negotiating over the ownership of the document. So no one suggested solutions like this when they were presented with the idea about the interactive table. But however, there were several very popular answers that many people repeated on both of the different surveys. And so we used these popular answers to help create some of our coordination policies. There are about 25 different coordination policies that deal with different types of conflicts, such as actions that disrupt the whole surface of the table versus conflicts over a single document. Because of time limitations today, I'm only going to talk about a few of them, and I'll talk about the scenario when there's a conflict over a single document on the table's surface. So to give an example of what we mean by a coordination policy, the default behavior in most systems is what we would call a public policy. Anyone at the table can interact with any object on its surface. And interacting with an object can mean several things. It can mean moving that object around the surface of the table. It can mean permissions to actually edit and modify that object. And it can also mean having the access rights to take a copy of that object back to your own personal device when you're finished working at the session. So we're interested, coordination policies can be applied to all of those types of interactions. So instead of having a public policy, one possibility is a private policy, where you can use the user identification capabilities of the device to ensure that only the person who actually owns a document can interact with it. So as you see here, the person on the right can move the document around, but the table ignores all interactions from other users. Now, of course, you work together around a table because you actually want to share things and interact with your teammates. So even though having things be in a private state all the time would help remove one of these classes of distracting conflicts, it would also inhibit natural sharing and interaction. So we've developed several interaction techniques that you can use to, in real time, transition objects on the tabletop between this private and a public state. That way you can keep things in a private state when you're not willing to share them and avoid conflicts, but you can make them accessible when you are ready to share. So one of these interactions is what we call releasing. So this is a handoff gesture that involves the coordination of both people to transfer access from the giver to the givee. So they both have to touch the document at the same time, and then the person who owns it has to actually choose to let go, and the permissions are transferred. We've also looked at using traditional semantics of regions of a tabletop to transition between these different phases. So people traditionally consider the area of a table that's right in front of them to be their own personal space. That's where they might put their notebook or their other personal objects, whereas the center is usually used for group focus and group tasks. So here you can see we've color-coded these different zones on the table. And when something is in your own zone, it's accessible only to you. But you can choose to move it into that black center area if you want to make it more accessible to other people on your team. So now the red user has made the document accessible to the blue user. You can also use the communicative properties of orientation to give information to the computer system about who should be able to access information. So for example, if I'm reading a document and I turn it towards you, that indicates that I want you to look at it too. So we've done the same thing here. When a document is still facing its owner, the system ignores other people's input, but you can actually spin it around to face other people, and that also transfers access permission to them. Finally, you can also use size to communicate whether or not you're willing to share something. For example, I'm projecting this content very large because I want it to be visible and shareable by you. And so the same thing applies on the tabletop. You can use small documents to signify that they're in a private state, or you can enlarge them to share them with other people. One thing that we wanted to know about these 4 particular techniques was whether some of them were preferable to others. Are some of them more intuitive and easy for people to learn to use? Are they more efficient ways to transfer access permissions? So to answer this question, we had 15 pairs of subjects come into the lab and perform document exchange tasks. So they would have a digital photo in front of them on the table that was in the private state, and their job was to use one of the 4 interaction techniques to change it into the public state so that their partner could take it away. And so each pair repeated this task. Yes?
Did you go back and forth? Or just
yeah, we went back and forth, so they would actually alternate.
But with the same thing, because once it's in the public state, does it stay in the public state, or does it revert to a private?
So they each, actually the way it started out, was there were two people sitting across from each other, and they each had a document in front of them. So, and one was accessible only to that person, and one was accessible to the other person. And so they each had to make their document accessible to the other person. And so each person had to do this 64 times, and each time we would tell them which of the 4 techniques to use. And obviously they also had time beforehand to practice and learn how to use each of the techniques. So again, because of time limitations, I'll just give you some of the highlights of that. One was that the relocate technique was significantly more efficient to use to transfer permissions. In fact, it took only half as much time as the other techniques. Relocate was also a winner in terms of ease of learning and usability. So for this, we measured how many errors people made using the techniques as an approximation to how difficult they were to learn and use. Although you can see actually all of the techniques have very low error rates, especially considering that these are people who only very recently learned how to use them. But people actually did not make a single error at all using the relocate technique, partly because it is very natural. People do understand the concept that the area in front of you is your personal space, and in the middle is a shared space. So in summary, coordination policies are interaction techniques to mediate group dynamics by helping prevent or resolve some of these conflicts. And as I mentioned before, there's a host of other techniques that I didn't have a chance to talk about today, but that I'd be glad to discuss with you more during my visit. The last issue that I'd like to discuss is considering how tabletop interface design is influenced by and can in turn influence the group dynamics of the people who are actually using the device. In particular, I'm going to talk about how tabletop interfaces can be designed to promote pedagogical goals. And this is some work that's in preparation for submission to CSCW this year. So education is an application domain that can really benefit from this new technology. Small group work is a very common pedagogical technique. It allows students a chance to work together, to practice speaking up and participating more in a safe environment. And in particular, foreign language classrooms employ a lot of small group work to allow students to have the chance to practice conversing in the foreign language with their peers. Digital technology also has a lot of applications in the educational domain. For example, if a teacher is busy helping other students in the classroom, it's nice that your digital system can still give you feedback about the type of progress you're making, even when the teacher isn't there to give you feedback personally. Also, from the teacher's point of view, the technology can record what students have been doing so that later the teacher can review and understand which students might need more help or which topics might need more emphasis in class. One challenge in allowing students to work together in groups is what's called the free rider problem. So that's when the smartest student in the group does the whole project for everybody else. And obviously that limits the educational experience of some members of the group. So what we're interested in is, can tabletop educational applications be designed in a way that they can help reduce free riders? So to explore this issue, we developed some software called the classification table that's intended to be used in a variety of foreign language scenarios. This particular example is for students who are learning to speak Spanish. So the idea is 4 students sit around the table, and obviously when they speak in the foreign language. In the center of the table is a pile of virtual clues, and these clues can be moved around and manipulated with your fingertips. So each clue gives a fact about one of the 4 countries in the corner of the table. So this one says this is the only South American country with coasts on the Caribbean and on the Pacific Ocean. And if you move it around, if it gets close to one side of the table, it'll turn and reorient automatically so that it's easily legible to the students who are using it. So the idea is that the students would discuss together in Spanish and decide which of the 4 countries they thought was correct, and then they would actually move the clue into that corner of the table, and the system would give them feedback about whether they were right or wrong. So we looked at 4 different variations of this application in order to understand the impact of each of these design choices on addressing the free rider problem and encouraging more equitable participation. And those are feedback modality, feedback privacy, the spatial layout of items on the table, and supplementary visualizations. And I'll talk about each of those in a little bit more depth. First, I'd like to discuss how we evaluated this application. We actually evaluated it in two different ways. First, in a series of traditional controlled lab studies where we had different students from the university come in and use a set of applications that we had designed. The second context was this past summer when we were fortunate enough to have our applications actually used as part of an English as a second language class at Stanford. And in this latter case, we actually worked closely with the teachers from this course to develop content that was appropriate for what the students were actually learning, what vocabulary and things they were learning in class that week. So the first issue we looked at was feedback modality. So we compared two different alternatives, visual feedback. So if you moved a clue into the correct place, it turned green, like in the upper right corner. And if you moved it into the wrong place, it turned red, and you could try again if you wished. Versus audio feedback, so if you put a clue in the right place, a positive ding would play on the speakers, and if you put it in the wrong place, you get that unhappy Windows noise, like and so what we wanted to learn here was whether providing this type of feedback through a different modality would impact participation levels, and also whether this would impact awareness about contribution levels, because you can imagine that if students have a more accurate idea about how much they've actually contributed relative to everyone else, that more accurate awareness could allow them to moderate their behavior and reduce free riders. What we found was that audio feedback impacted participation in terms of the amount of communication in the foreign language. The amount of time that students actually spoke to each other rose significantly, being 75% instead of 60% as when they had the visual feedback. And we suspect that this is because the audio sort of inserted noise in the environment and broke the ice. It made it less awkward for students to begin speaking on their own. Not surprisingly, the audio feedback also allows students to more accurately assess how much they're contributing relative to everyone else. Again, probably because it really pushes this type of information towards you. It's much easier to not notice if another member of your team has contributed an answer when the only change is visual and it might be far away in the corner of the table. The audio makes that much more obvious. Another issue that we considered was whether feedback was public or private. And so in this experiment, we considered two different variations on the audio feedback design. So feedback that was played over speakers that everyone in the group could hear, or a system similar to the one that I mentioned earlier where people wear earpieces in one ear. And so in that case, only the student in the group who actually touched the clue and was brave enough to decide to put it in one of the corners actually hears the feedback about whether it's correct or incorrect. In this case, we're particularly interested in whether private feedback might encourage shy or underperforming users to increase their level of participation in the activity, because they would ideally feel less self-conscious, perhaps, about getting wrong answers. Yeah?
To be clear, when they got the wrong one, they only got audio feedback, the visual feedback wasn't.
There was no visual feedback, right. It's either audio or visual, but not both. Yeah. So some highlights of our findings here. What we found was that with the private feedback, students reported to us afterwards that they felt less embarrassed and they felt more comfortable. But we found when we actually studied the logs of participation in the activity that there was virtually no change at all in terms of actual levels of participation. And there are a couple of reasons why this might be. So first, this data is from our use in the lab setting, not from the authentic classroom use. And so some of the pressures related to worrying about what your peers think of you and feelings of embarrassment probably don't operate in that context. People aren't really going to see the other people from the experiment ever again, probably. So you might, I would suspect that you might actually see more real changes in behavior if you tried this out in a more authentic scenario. Another issue that we considered was the spatial layout of the data in the application. So for example, the clues could begin aggregated in the center of the table, like I showed you before, or you could instead randomly sort of assign them to be located nearer to some of the students, with the idea that this might make people feel more responsible for being more involved with the material that was located near them. So again, we're interested in whether this type of subtle change can impact participation equity. What we found was that the layout where you located items in piles near to different people did in fact result in more equitable participation. So again, if you look at the standard deviation of interactions with the table among groups, you see the lower standard deviations when people did an activity where things started out in piles, as compared to when those same groups did a similar activity where everything started in the center of the table. However, what we were surprised to find afterwards was that students commented to us that this felt less like a team activity, that when things started out in the piles, they tended to just sort of work on their own on the material that was in front of them instead of being more involved in discussing with the group. So I think looking further into how you can get this type of benefit of encouraging more participation, but still keep the group and team-oriented feel to an application is an important area to look further into. Finally, the last variation that we tried was supplementing the tabletop with what we call interaction visualizations. So these were real-time histograms that you can see are located in front of each user's seat. And these update to reflect each student's contribution to the activity relative to everyone else in the group. So this was inspired by some of Joan D'Amico's work at MIT, where she's looked at how ambient visualizations can influence participation in group activities. So we actually had two different variations of our interaction visualizations. In one case, they showed how many clues you had actually classified relative to everyone else in the group. And in another case, they showed how much you were speaking in the foreign language relative to everyone else in the group. And so to measure that, we had people wear personal microphones. And of course, we also compared this to a third condition where there were no visualizations present. So again, will providing this very obvious awareness information help reduce free riders?
Is there a difference between when you can see your score and everybody can see your own score?
Right, and so that's something that we've left for future work. Yes, it's also you can imagine showing these more on private displays, and you could show more detailed information. And it has a lot of interplay with the previous scenario where I talked about feelings of embarrassment versus privacy. And in fact, this design was one thing that the teachers in the ESL class we worked with had very mixed feelings about, because they were very concerned about how this would impact students' self-esteem. They didn't want it to feel like a competitive activity. One of the things that we tried to do in response to their concern, let me make this a little bit bigger, is to try and we grade out, so this is your own color, and we sort of grade out everyone else's color to make it more like you and everyone else instead of you and specific other people, to try and make it a little bit less competitive that way. But yeah, you can imagine that still creates sort of competitive feelings. Yeah?
So two questions. One, did you explain to the students beforehand?
Yes.
This is what we're measuring.
We explained to the students what the visualizations were showing, and we also explained to them that it was just for their own information. It wasn't going to influence their grade or their score on the activity. It was just in case they were interested to know.
And so is the line, what is the line?
Oh, the line shows the average. So it shows the average level. So if you're equal to the line, then you're sort of...
So I mean, one way you could do this, right, is just show, you don't show any of it.
You could just show the line, yeah. Yeah.
Well, it's loosely it's you versus everyone else.
Yeah, and that's a design that we also considered. So we sort of tried something in between as a first pass. Yeah, Patrick.
In my experience, sometimes there's an element in class, more active students just pull themselves back for a couple of seconds, and then the less active students will actually, take the stage. We've done introducing sort of timeouts for those that are very active who've already filed 20 of them or so. Just introduce a couple of seconds of lag until they finish the next one.
That would be a really interesting idea. we did not consider actually using the identification capabilities of the table to prevent people from interacting. The idea is that this information, in addition to being helpful for under-participators, could also let people who are over-participating realize that they've over-participated and perhaps choose to moderate their own behavior. But the alternative you suggested would also be interesting to explore. So what we found was sort of a mixed bag. So we found that the visualization that showed how much people were speaking in the foreign language did increase the equity in terms of how much people spoke. So people who noticed that they were speaking less began to speak more, and the distribution of speaking became more equal. Whereas the visualization that showed how many clues people had classified had no effect at all on behavior. And I think the difference between these two things, based on our actual observations of the group, is related to sort of filler content. So what we saw happen with the visualization that showed how much students were speaking was students who noticed that they weren't speaking as much would speak more, but they didn't actually offer any more answers to the activity. So they would give a lot of organizational speech, like, oh, did anyone look at this one yet? Oh, John, what do you think? But they didn't offer any answers. And of course, that type of filler behavior wasn't possible in the other case. So if you noticed that you hadn't classified as many answers as everyone else, well, the only way that you could increase your score for that was to actually take a try and offer some answers. And so I think this is interesting. I think it shows that this type of awareness information can make noticeable changes in group behavior. And I think what's interesting would be to look at how you might redesign this information to make those changes in behavior actually be pedagogically valuable rather than only filler activities. I'd also like to briefly mention another project in this space of looking at how tabletop interface design can impact educational activities. This is work that was done in collaboration with Anne-Marie Piper, who was a graduate student in the School of Education at Stanford and actually works here at Microsoft now. And this project is called SIDES, Shared Interfaces to Develop Effective Social Skills. So what we did was developed a tabletop board game specifically tailored for use by students with Asperger's syndrome. So Asperger's syndrome is an autistic spectrum disorder where individuals may have difficulty socializing and communicating with other people. So several aspects of this board game are specifically designed to encourage more social negotiation and interaction. So for example, I'm not sure if you can see in the picture, but there are those little white buttons around the edge of the table. And certain key activities in the game require all of the students playing to all vote and press their buttons together at the same time. And so the idea is that in order to achieve this coordinated action requires communication and negotiation from the students. And we were fortunate to actually be able to have this system used by students from a local special needs school. So again, I'd be glad to talk about that more afterwards. But we're running short on time, so I'd like to wrap up. In summary, what we found is that user interface design can enhance the work experience around interactive tables. In particular, small changes in UI design can really allow more effective teamwork processes with these devices. For example, we talked about multi-user coordination issues and how interaction techniques can help reduce those types of conflicts among users to reduce disruptions to workflow. I also talked about supplementing a tabletop with sources of private content in order to enable more natural work styles and more parallel exploration of information. And also about our work in the educational domain, looking at how subtle changes in UI design can really influence different group work and participation levels around these devices. In the future, I'm interested in not only continuing to explore the tabletop form factor, but looking at a variety of ways that technology can better support co-located group work processes. As I mentioned earlier, in business, at school, at home, group work and meetings are a very big part of many of our lives, and current technology solutions really fall short in helping out these areas. In particular, I'm interested in looking not only at tables in isolation, but as part of a larger environment that includes other types of large displays as well as personal devices that people bring with them. And in particular, looking at how these types of environments and interaction techniques can be designed to facilitate effective teamwork. Another important issue that these types of environments bring up is issues related to security. For example, when people are working together and transferring content between personal devices and shared devices, it's important to create systems that allow users to understand where their content is and who has control over it. Also interested in educational technologies. I've really enjoyed these latter projects that I've done over the past few years. Obviously, some of this can relate back to these multi-display environments and how they can be designed to support education. One challenge is that these types of installations are very expensive, and realistically, many schools and universities can't afford enough table displays and large displays to support students. And so I think looking at how commodity devices that many students already have, like cell phones and digital cameras, can be combined with maybe only a limited number of larger shared devices in order to create compelling interaction is an important and practical way to look at supporting educational group work. I'm also interested in how search interfaces can be redesigned to facilitate younger students learning how to search and query more effectively. And again, I'd be glad to share some of my ideas with that about you during some of our individual meetings. Before I close, I'd like to acknowledge all of the people who contributed to the table projects that I presented today. I'd especially like to thank Merle for donating Diamond Touch devices to our lab, as well as all of my other collaborators and co-authors. And I'll stop here and take any questions that you might have about this work. Thank you. Yeah.
So project forward, when these become integrated, you don't need a projector anymore, and say 10 years in the future, and they're $1,000 or something, how do you think this will change the work?
Right. So I think some of the most compelling applications for these devices, like where I expect to see them in 10 years, hopefully in schools. I mean, the teachers that we worked with were very excited about their potential to support group work. I can also imagine them in people's homes. As I mentioned, we worked with biologists on applications for tagging and labeling photos with metadata content. But we noticed from this activity is just the table form factor as a way to share and view digital photos and also to organize them. I can imagine that that would actually be a very compelling home application for home use, for sharing photos and storytelling, and even almost as an ambient display in your living room showing off all of those things. So that's someplace where I envision them becoming prominent as well. Yeah?
The Merle Diamond Touch, at least as far as I know, the ones I've seen are fairly small. Have you looked at or played around with larger form factors at all, and do you think that really changes which techniques are going to work?
I think it does. It's important. And I have not had the opportunity to play with larger form factors to an extent because of the limitations of available technology. But I do think that does impact some of the interaction techniques. For example, just reach issues, right? If you physically can't reach some parts of the table, then you need to use some of these gestures. So for instance, actually, I didn't talk that much about our work on cooperative gestures, but that involved a lot of gestures to assist with reachability, such as throwing things across the table. And the cooperative aspect of it is that your partner, who's receiving the items you throw, can do a gesture to determine both the exact location and the orientation and even the size that things end up at, so they can fine-tune. And what we found when we tested those on our 4-foot by 3-foot Diamond Touch was that users, when they rated those gestures, said these are stupid gestures that aren't useful because why would I ever do this? I can reach out. And so I think that you'll find that those interaction techniques are much more useful at a large table. And you can imagine that you could do different things with a large table that you don't need to do with a small table. So it might be more useful at a large table. You can replicate information to people, say at a conference-sized table, to make them more aware maybe of what's going on at the other end. And that's an advantage that you really couldn't get with a traditional piece of furniture. So the answer is yes. I'd really like to try out different size form factors and shapes, and maybe even piece by piece tables that you could assemble on the fly. Like you can imagine making an ad hoc table out of several tablet PCs that everyone puts together, which would be really interesting to look at.
Anybody else? All right, let's make
Great. Thank you.